After the tokenization is done, the input text are sent for something called embedding, and the embedding is sent to the neural network or the actual processing of the transformer architecture, which is the attention mechanism, feed forward, etc. Now, what is this embedding? We can consider this as word embedding also, image embedding also, video embedding, it can be text embedding, it can be audio embedding, etc. The concept remains the same irrespective of what the input is. There are embeddings for sentences also, which falls in the category of text embedding itself. But the process of embedding or the concept of embedding remains the same throughout. But what is the purpose of embedding or what is embedding? It is also known as vector embedding, and the purpose of embedding is to convert the text, the image, video, audio, etc., all these different data formats to vector. That is the purpose of embedding. And what are vectors? Vectors capture meaning of the words. I have already talked about vectors in the first section of this course. But what you'll see if you read any books, if you read in the internet, it says that the embedding are vectors that capture the meaning of the words, which is correct, but they also mention something called in a higher dimensional space. Now, this is where a lot of people might get confused because for me, I think it's a little over description. When I talk about higher dimensional space, we are bringing in astronomy, we are bringing in a lot of complexity. So I'll not use this higher dimensional space. First of all, let us try to understand what embedding is. The purpose of embedding is to convert any type of input to vectors. And you already know what vectors is. The reason it is converted into vectors is because the neural network models, they do not understand text, they do not understand pixels or pixels with motions or audio data, etc. Pixels because there is image and video both. The neural network that is used after this step, the model does not understand either sentences or pixels or images. So they have to be converted into mathematical representations. That's what embedding does. It converts the input, which can be either text or image or video or audio or anything of that sort, into vector format, which is nothing but a mathematical representation of the input with some meaning to it. And embedding, which can be text embedding or image embedding, anything are done by some pre-built neural networks. I'll talk about how the neural networks create embedding shortly, but when it is used in the transformer architecture, the embeddings are already given. It means that there are neural networks available to do vector embedding, which means the text can be converted to an vector embedding, or a word vector, an image can be converted to an image vector, video can be converted to a video vector, etc. And each type of data has its own embedding neural networks, which means we cannot use the same neural network that we use for word embedding to embed images. So the vector embedding neural network for image would be different than the word embedding, and it would be different from the video embedding, and it would be different from the neural network which will do audio embedding. So the machine learning model, the machine learning neural network model to embed the text data would be different than the model that embeds the image data, and also different from the model which will embed the video, audio data, etc. The embedding is already there for existing vocab and it is stored along with the models. Now, these are some of the points that you should know. Whenever you download a model, whenever we use an open source model, or whenever you use a model which is hosted on cloud, all of them already come with their corresponding vector embedding. And that vector embedding would be there for all the tokens which are there in the vocabulary list. So I've already told you what a vocabulary is. A vocabulary is nothing but the unique tokens for a model. And for each unique token, the embedding would already be there along with the model. So this is the GPT-2 model. And if you go to files and versions, there will be some file with the extension of safe tensors. Yeah, this is the one. This file would contain the vector embedding for this model for the vocabulary. So this is the vocab, and the corresponding word vector or image vector would be there in this file, which is model.savetensors. Now, if it is a large language model, it will only contain word vectors. If it is a multimodal model, which can process images, which can process text, then the vocab would contain tokens for images, text, and videos, and their corresponding vector would be there in this file, which is model.savetensors. So the vector embeddings are stored as .savetensors extension. In most of the cases, that would be the extension, and there can be scenarios where it is stored as binary also, but the situation would be very less. Almost 99% of the times it will be in .savetensors extension. In the previous slide, I had told you that the vectors also capture the meaning of the words. Now that's a little non-intuitive or confusing and interesting also at the same time, because how can you capture meaning or emotions using mathematics? How do you provide meaning of a word which contains its related emotions also using maths or using mathematics? Now here one thing that I wanted to underline is that mathematics is a very strong subject, and I think everything around us is mathematics. So if you look at any object around you, I think you can represent that object using mathematics, and the embedding actually tells you how. Let's do a small recap. Now, this is a snapshot or a screenshot of the deck that I had shown you in section 1 or part 1. First, let's do a recap of what is vector in the context of machine learning. Now, there are different dimensions of vector. Now, this is a vector which has 8 dimensions, which means that it has 8 elements in an array. That's why I said dimensions in the higher space might be a little too over engineering. So it's better to consider a vector as a list of words or an array of numerical numbers. It can be discrete, it can be continuous, or it can be a mix of both. So that's what a vector is. Now, keeping that in mind, how do you capture the essence of a word using vector or using the embedding? Now, what is embedding? So if you have a word, let's say, the word would be converted to the mathematical representation like this, which is in 8 dimension, which means that we can capture the meaning of a word using a list data type in Python, or you can consider that as an array also, or array of mathematical numbers. So let's say this is the array which contains 8 elements. Now if I describe it in vector format, we can say that this is a vector with 8 dimensions, because there are 8 places to store different numerical numbers. And this 8 dimensions or 8 elements is the size of the vector, which is nothing but the number of dimensions. If I describe it programmatically, it means that the array has 8 elements. Okay, now let's look at a word which is building, and we'll try to create a vector embedding of the word building, and in doing so we'll try to capture the meaning of it, right? And we'll call it as word embedding because we are creating vector embedding for a word. That's why you can call it as word embedding also. If you are creating vectors for an image, that would be an image embedding. If it is for a video, that would be a video embedding, etc. So we are doing some word embedding. Now let's say these are the dimensions that we define, the structure of it. So whether it is a structure or not, whether the building is actually a building or not. Now we can call it as structureness, which describes a property of the word. Now let's say it is 0.77, which means that yes, in most of the cases it can be a structure. It can be property also, or propertyness. Let's say the value is 0.61. And there can be other dimensions also, like workness, behaviorness, industryness, processness, etc. So the first dimension, structureness, defines whether it can relate to a physical structure or not. The second one is property. Let's say you are working on something, some property. I'm not even sure why did I put it here, but anyway. Then we have workness. Let's say I am building a presentation. That is, I'm working on something, right? I can say that I'm building a presentation, or I'm building a clay model, let's say. It can be that word also. Building can be there also. Behavior also, like whether I'm able to build relationship with others or not. That is another dimension. It can be related to industry also. Let's say I'm building a training industry, I'm building a video industry or a content industry. So it can be that also, and a lot of other things. Now you might ask, where am I getting these numbers from? I have put these as random numbers, but there's a way to get these numbers, which I'll discuss shortly. But before that, let's try to understand the embedding a little bit more using the word run. These are the dimensions. First is the exerciseness. What do I mean by this? Let's say we wake up in the morning and run daily. That is an exercise. It can be businessness also, or the word run can be related to business also. Let's say I'm running a course creation website, www.3am.in. So I'm running a business. It can be related to that. It can be control also. For example, who is running the house? In most of the cases, I think in almost all the cases, it would be the wife who's running the house. But we can use this word run in the context of controlling something also. Who is running the show? Who is running the house? Who is running the narrative, etc. Then it can be flowness also, like if someone cries, let's say, tears are running down his face, or tears are running down her face. So that is describing the flow, or that is describing the flow character. Then it can be job also. It can be duration also, how long the web series is going to run, how long the movie is going to run. I mean, we do not use it as much, but it can be used. It can be technology also. For example, how long, let's say, the Java program is running for? How long has it been that the program is running? So these are the different properties that can be associated with the word run, right? Now, these properties are called dimensions. And who decide these dimensions? How many dimensions should be there? It is decided by the machine learning engineers who create the model. Whoever was involved in creating the Gemini model or the GPT model or the Llama model, they would decide how many dimensions would be there. And the dimensions will not be there as header. I'm using this header just to give you an idea of what word embedding is. Anyway, now let's look at an interesting stuff. Let's use this a word run in different sentences. First is, he runs 10 kilometers daily in the morning. In this case, we know that we are talking about exerciseness. If I use the word in another sentence, she is running a very profitable and successful business. This is related to either business or controlness, any one of them. It can be jobness also. River runs along the road, which is the flowness. It is describing the flow characteristic of river. The Python program is still running, which is the technologiness of the word. Now you see, as humans, we can comprehend the meaning of the same word in different sentences. How do you do it? We see the word with the context of the entire sentence. And that's when we know what is the meaning of this word. So if I give you these two sentences, he runs 10 kilometers daily in the morning and she is running a very profitable and successful business, obviously you would not say that both are similar. This run and this run is very different. The reason is we are able to define this word with respect to the sentence. And this is how humans understand a sentence. And interestingly enough, this is how machines also understand the meaning of a word. And we'll talk about it in the attention mechanism. But in this case, the value, let's say, of run would be maybe some portion of 0.35, some portion of maybe 0.08. In the first one, we definitely know that it is exerciseness. So the value of this run would be 0.9, then maybe 0.000 and other stuff. So this is what word embedding is. And this is how, using the vector list, we can describe a word and its corresponding meanings. And there can be different meanings, and we can capture the meaning in different vector dimensions. In the first one, I'm capturing the meaning of exercise. In the second one, I'm capturing the meaning of business, and so on. So this is how, using mathematics, we can capture the meaning or emotion of a word also. And the way it is done is that the word is provided different numbers, which is nothing but a vector. Again, vector is nothing but a list or an array which contains different continuous or numerical numbers. So using different numerical numbers, we are essentially describing different property of the same word. And now when to use what, that would depend on where the word is getting used and which sentence. The first sentence and the last sentence are completely different. We know this because the last sentence is related to Python program, which is a technology, and the first one is related to someone running in the morning, which is exercise. And the same thing is done by AI models also. We'll see this in the attention mechanism, but let's try to understand embedding a little bit more. The reason I am putting so much of emphasis in embedding because this is a very important concept, and there's something called vector database also, which we'll talk about later on. Embedding is used there also. The reason they are called vector databases is because those databases can store vector embeddings also. Anyway, let's try to understand embedding for two words. It's the same dimensions: exerciseness, business, control, flowness, etc. Let's take the word run, and these are the vectors of the word run. So exerciseness is 0.9, businessness is 0.35, controlness is 0.4, and so on. Let's take another word, which is MacBook, and this is very much different than run. If I put MacBook within the same dimension, the exerciseness would be almost 0, and actually it will be 0. It will not be even 0.00001. For businessness, it can be very high because MacBook is used in a lot of business. Controlness, it will be 0. Flowness, it would be 0. Job, yes, we can perform our job using MacBook laptops. Durationness, you can associate MacBook with duration also. Let's say use MacBook in a sentence like how long my MacBook is running for. What is the battery duration of this MacBook? And if we talk about technologiness, it is definitely 1, but run, actually it should not be 0.001, it should be 0.00. Run has nothing to do with technology. Right, so now if you see, if you compare these two words, they are different completely. They have some similarity in the business dimension, and that's it. So the vectors of these two words are also very different. I'm using only 8 dimensions here. Even if you use more dimensions, it would be same. Let's use another word called cloud, and the dimensions would be very different. Exercise would be completely 0. Business, yes, it can be pretty high because we can run business using cloud technologies. But cloud has something to do with weather also, or nature also. I have not put the dimension here, but there would be definitely some dimension with nature wherein cloud would score more than 0.9. Controlness completely 0. Flow should not be 0 because cloud can flow in a certain direction if we are talking about the clouds in the sky. Jobness, yes, we can consider cloud in the jobness. Let's say there's a role opened for cloud architect or cloud solutions architect. That is related to job. So that's why the score might be a little high. Whatever durationness, 0. Technologiness, yes, completely 1 because cloud is related to cloud technologies. Now there can be weather also, it can be related to nature also. I have not put those dimensions. These are the 3 different words that I have represented using the same dimension, and they do not match at all. Right? MacBook and cloud match because we can use it in the business, we can use it in job, but cloud and run does not match in a lot of places. Now, when to use what? That would depend on the sentence where these words are getting used. And that is where attention mechanism comes. But I just wanted to show you what embedding is. The number of dimensions would be much higher. Typically, I think it is 300 dimensions or maybe 512 also for all the AI models. So if you have, let's say, 300 dimensions, you can definitely capture almost every essence of a word. In this case, I have not captured the nature essence of cloud because clouds in the sky would be related to nature. Clouds are flowing towards east, that would be the flow nature, etc. I have not captured those, but definitely those would be captured when we use embedding in AI model. Now, a question to you: how do you find out similarities between the words? How do you find out whether the words are similar or not? I've talked about it in the first section or part 1. Pause the video and see whether you can answer it or not. So there are 2 ways. The first one is cosine similarity and then dot product. And in most of the cases in AI models, cosine similarity is used.